In the last class, we talked about the calculation of velocity and acceleration of a rigid body which undergoes both rotation and translation or combined motion. This class we will talk about the special type of combined motion of the rigid body which is known as rolling. When you talk about rolling of a sphere, rolling of a cylinder, rolling of a disc come into our mind. A billiard ball, when you cue, after some time it starts pure rolling. Rolling of a volleyball, cricket ball on a horizontal surface, on an inclined plane. When you leave a body, a cylinder or a sphere or a disc, it rolls down. And in the concept of rolling, we can see that the points of contact of the bodies, for instance, the ball rolls on the ground. The lowest point of the ball does not slide at all. This is the concept of sliding. It slides. This is the cylinder. The cylinder it slides. It slides. There is a relative velocity between these two surfaces, between the lowest point of the surface and this surface. This sliding, this case of sliding, when there is a relative velocity between the points of contact. But in the case of rolling, when you roll like that, this is the case. This is the case of rolling. In the case of rolling, the surfaces don't slide. This is the case of rolling. Rolling, and this is the sliding case. This is rolling case. Rolling. Two surfaces roll over each other. Two surfaces roll over each other. So you can see that there is no shearing of the skin. No shearing of the skin. But if you rub these two surfaces, that is called sliding. So rolling is a concept where the surface number 1 and the surface number 2 at the lowest points are the instantaneous point of contact P and Q. Let P and Q be the instantaneous points of contact of the two surfaces 1 and 2 respectively. Point 1 is the point of contact surface 1. Let me repeat. Point P is the point of contact of the surface number 1. Point Q is the point of contact of the surface number 2. If these two surfaces 1 and 2 roll over each other, no relative sliding happens. No relative sliding occurs between the contacting points. Between the contacting points P and Q. This means that relative velocity between P and Q is not equal to 0. For sliding, but for pure rolling, relative velocity between these two points is exactly equal to 0. This is the condition for rolling of one surface over the other. Let us take the velocity of one is v1. Velocity of point P of the surface 1 is vp, suppose. Velocity of the point Q of the surface 2, let it be vq. So, relative velocity between these 2 points can be written as vp minus vq, or vq minus vp is equal to 0. This means that these 2 points of contact must move with some velocity. So, we can write the contacting points must move with some velocity for pure rolling. Vp is equal to Vq. Let me give some examples now. Let us spin the cylinder in this way and project the cylinder with the velocity of center of mass, say Vc. This is center of mass, this is the last point P, the last point Q, or the contacting point Q of the horizontal surface, and this is the last point or contacting point of the rolling body. Let us calculate the velocity of this point P. Let us calculate the velocity of the point P and equate it to velocity of point Q. Since this point Q is situated on the horizontal surface and the horizontal surface is fixed, fixed surface, rolling body on a fixed horizontal surface. Our condition is this point velocity must be equal to this point velocity. What is the velocity of this point? In the last class, we talked about the calculation of velocity. A velocity of any point, say center of mass, is given, and angular velocity of the rigid body is given. Its velocity will be equal to how much? This is velocity of P with respect to C, that's equal to r omega, and this is velocity of C. So, velocity of this point will be equal to Vc minus r omega I cap, and velocity of Q is equal to 0. So, the condition is equal to Vc equal to r omega. And if you differentiate both sides, dVc by dt equal to r d omega by dt. But this is nothing but acceleration of the center of mass. If center of mass has some acceleration, suppose A, and alpha of the rigid body is the angular acceleration. So, AC is equal to r alpha. These are the condition for rolling. Conditions for rolling of a body on a plane surface. If we just twist the problem by giving the opposite spin or anticlockwise spin, then what is the condition for rolling? You cannot write Vc equal r omega or Ac equal r alpha. For this, velocity of the point P with respect to C will be in this direction. If this body spins in this way, this point P moves in this way with respect to the center of mass, whereas the center of mass moves in the same direction. Therefore, the velocity of the point P is equal to Vpc plus Vc equal to both Vpc and Vc are having same direction. Vectorial you can write like this. So, instead of Vc plus r omega, it should be Vc plus r omega. So, instead of Vc minus r omega, it should be Vc plus r omega is equal to 0. So, Vc equal to minus r omega. Therefore, dVc by dt is equal to minus r d omega by dt, Ac equal to minus r alpha if alpha will be given in same direction. So, when we write Vc equal to r omega, when you by heart or mug up this formula, we have to also by heart or mug up remember the conditions. When Vc is equal to in this direction, omega is in this direction, this is correct. Or Vc is equal to in this direction or omega in this direction, then it is correct. And when Ac is in this direction, alpha in this direction, you cannot write Ac equal to r alpha. If alpha will be in this direction, then this r alpha is the acceleration of this point P with respect to C in tangential direction. I will be coming to this point. This is the AC. These two acceleration must be equal because acceleration of this point P along tangential direction will be 0. That again I will re-explain all these things. I will emphasize on this fact later on. But Vc is equal to r omega when omega is in this direction, Vc is in this direction, or omega is in this direction, Vc is in this direction. Let us take another example. Suppose this spins in this way with omega. Omega is equal to 2v by r. This is suppose v center of mass velocity, and this surface moves with velocity v dash. Find v dash so that this sphere rolls on the surface S. For pure rolling, what is the condition? Suppose the center of mass, this P, this is Q. These 2 points must be having some velocity. And velocity of this point P is equal to Vpc plus Vc is equal to Vq. Velocity of P with respect to C, if it is spinning in this way, Vpc will be backward. But Vpc is equal to minus r into omega I cap as you discussed, and Vc is equal to v I cap, and this point velocity is given as v dash I cap. So the condition is v dash is equal to v minus r omega. or omega is equal to 2V by R. R are getting cancelled, you are getting minus V. So V dash is equal to minus V. Let us analyze the negative sign. The negative sign signifies that this plank or the surfaces must move in the opposite direction of the assumed direction. The negative sign of the answer means that the plank or surface S must move opposite to the assumed direction. Our assumed direction is along positive x direction, but we got negative answer. Therefore, this plank or the surface should move in negative x direction. Therefore, the surface S must move with velocity V dash is equal to minus V I cap in negative x direction. This surface should move in this direction, not in this direction. This is the answer. And if instead of omega is equal to 2V by R, if we write V by R, then this will be exactly equal to 0. The surface, this means that the surface S must move, must be kept, and this is another question. And if we take omega, suppose V by 2R, then up to this all the steps are right, this is also right. Omega, if you put V by 2R, this will be equal to, up to this also it is correct, R are getting cancelled, and ultimately you are getting how much? V minus V by 2 is equal to plus V by 2, and the positive sign signifies that the surface S must move towards right with the speed V dash is equal to V by 2. This is the idea. Well, let us take another problem. This body is rolling on this fixed horizontal surface, and this is a plate. Here also there is no sliding. Here no sliding, here also no sliding. So you can say that this body rolls perfectly at these 2 points. The body sphere rolls at P and Q perfectly. Condition is that for pure rolling, here Vp is equal to 0, because this is P, this is M, This is Q and this is suppose N. Let us pull the plate with velocity v. Now question, find velocity of the center of mass or the center of the sphere and find the omega. This is the question. Now for solution, for pure rolling, if the body rolls at P and Q perfectly, for pure rolling at P, these 2 points velocities are equal. Vp is equal to Vm, but this surface is fixed. When this is fixed, Vm velocity must be is equal to 0. Vm must be equal to 0. So velocity of m will be equal to 0. Therefore, this point velocity will be equal to 0. Well, let us assume that center mass velocity is towards right and the angular velocity of the body is omega. Let it be clockwise. You can assume anti-clockwise also. You can assume Vc in opposite direction also. It's your use. Pure rolling at P for pure rolling at Q. Vq must be equal to Vn. These 2 points must be having some velocity as per the condition of pure rolling. Well, Vq, this velocity of Q with respect to C, that's equal to r omega, and this velocity of C. Therefore, Vq is equal to Vc I cap plus r omega I cap as per the previous discussion of the velocity calculation. Velocity of this point, that's nothing but the velocity of the plate, that's equal to V I cap given. In this way you can calculate Vc plus r omega is equal to V. Since Vp is equal to 0, P with respect to C moves in this direction with the velocity r omega, and you bring the velocity of the point C at this point. So Vp is equal to Vpc plus Vc is equal to 0. But what is Vpc? Minus r omega I cap plus Vc is equal to Vc I cap is equal to 0. This gives us Vc is equal to r omega. Equation number 1. And this is the equation number 2. We have 2 equations and 2 unknown quantities. One unknown quantity is Vc, another is omega. Solving. Solving equations 1 and 2, we can get, you write Vc is equal to r omega, here plus r omega is equal to V, and omega is equal to V by 2r, answer. And Vc is equal to r omega, you substitute omega, that's equal to V by 2, answer. So Vc equal plus V by 2, our assumed direction is correct. Omega is plus V by 2r, our assumed direction is correct. This is a nice problem. Let us take another example. Plot number 1 and plot number 2. To pull the 1 in this direction with the velocity v and 2 in this direction with velocity 2v. Find velocity of the central point of the cylinder Vc and angular velocity of the cylinder. This is given, this is given. Now we have 2 points P and Q. You draw the diagram separately. At this point Q is Q1, at this point is Q2 suppose. This point is P1 and this point is P2. For rolling, at P, these 2 points must have some velocity. For rolling at Q, these 2 points must have some velocities. If we assume B, C and omega as the velocity of this point C and angular velocity of the body respectively, at this point velocity can be written as V plus R omega. At this point velocity is given as V plus R omega in this direction. So Vp1 is equal to minus V plus R omega I cap, and Vp2 is equal to, this is pulled in this direction with velocity 2v. In which direction? Negative x direction, therefore it is minus 2v I cap. Therefore we can write V plus R omega is equal to 2v. This is not V, this is Vc actually. Vc plus R omega is equal to 2v. Equation number 1. Equating the velocities at these 2 points P1 and P2, we got this equation 1. Similarly, this point velocity Vq1 is equal to Vc plus R omega I cap, and this point velocity is given as plus V I cap. So Vc plus R omega can be written as V. Here R omega is in negative direction, therefore instead of plus it should be minus, because velocity of this point is equal to velocity of this point with respect to center mass, that is minus R omega, plus velocity of this point, that is Vc. So it should be Vc minus R omega, this is the velocity of the point P1. Vc plus R omega is a wrong result. So Vc minus R omega you have to write in which direction? Minus a negative x direction. Therefore we can write instead of Vc plus R omega, we should write Vc minus R omega. So Vc minus R omega is equal to 2v. This is the correct answer, a correct equation. And for this point Q1, Vc is in this direction and R omega is in same direction, because Vq1 C, this point moves with respect to C in this direction, that's R omega, and you have to add velocity of the center of mass also. So the net velocity or the total velocity of this point Q1 will be equal to Vc plus R omega. Therefore this equation Vq1 will be equal to Vc plus R omega I cap, and this point velocity is at B. So Vc plus R omega is equal to V, equation number 2. Now we have 2 equations for 2 unknown quantities. What are the unknown quantities? Vc and omega. Solving these 2 equations, we can get equation 1 and equation 2. base A minus r omega is equal to 2v. Base A minus r omega, that the velocity of this point, minus r omega plus Vc will be equated with minus 2v, and here direction wise also you may write in this way, but that's actually incorrect. Vc Vp1 is equal to Vp1c plus Vc. Vp1c is in which direction? Minus r omega I cap, and Vc is equal to Vc I cap. So this Vc minus r omega I cap instead of minus of this. So Vc minus r omega will be equal to minus 2v. Equation number 1. And at this point, we got this equation. At this point, we got the equation Vc plus r omega will be equal to v. So Vc is equal to minus v by 2. We have taken velocity of this point in positive x direction, but we are getting negative answer. Therefore, the point C moves towards left. And substituting Vc either equation 2 or equation 1, you can get Vc is equal to minus 2v plus r omega, or Vc is equal to minus v by 2 is equal to minus 2v plus r omega. So r omega is equal to 3v by 2. So omega can be written as 3v by 2r. Since it is positive, our assumed direction of omega is correct, but our assumed direction of omega is clockwise. Therefore, is a correct answer. And Vc is equal to minus v by 2 I cap answer.